I was curious what old Canadian curriculums used to look like. So I Googled old Ontario curriculum documents, and I was shocked by how easy it was to find all this old documentation from the early 1900s. Specifically, I found this documentation which had all the examination papers from 1934. And these were examinations for middle schoolers trying to enter high school. And now, what I found really interesting was that these entrance exams were actually abolished in 1949. So we no longer have to write exams in order to get into high school. And now, in this documentation, I actually found this old algebra exam. And so I wanted to see if I was actually smart enough to do an algebra high school entrance exam. So are you ready to write a 1934 algebra exam? Because I am. Let's get into it. And I should preface that I did not look at this exam before starting this video. And I also did not use a calculator because I'm pretty sure they didn't have calculators in school in 1934. So let's start with question number 1. We were asked to factor these polynomials and trinomials fully. Looking at question 1a, we have this polynomial. Now right away I thought I need to collect some like terms. So I rearranged the equation a little bit. Now looking at the first two terms, I realized I could factor out 6ab. Looking at the last two terms, I realized I could factor out b squared. And that left me with this equation. From here, I realized I have a common factor of b and a common factor of x cubed minus y cubed. And when I factored those terms out, I was left with b times x cubed minus y cubed times 6a minus b. But I didn't stop there, because I realized that x cubed minus y cubed is a difference of cubes. So I could factor that even more by writing it as x minus y times x squared plus xy plus y squared. And with that, I had the fully factored solution. Of course, I checked my work by multiplying out all the brackets, and since I got back the original polynomial, I would say that I got the question correct, and I gave myself a check mark. And then I moved on to 1b. So now looking at question 1b, here we have a trinomial. And I know it doesn't obviously look like it's in the form ax squared plus bx plus c, but we can factor this as if it was a quadratic equation. And so the first thing I had to think about was what two numbers will multiply to get the coefficient 4. We have 4 times 1, and we have 2 times 2. And to get our variable a to the power of 4, we can just do a squared times a squared. And then looking at the last term, 225 times b to the power of 4, I realized we can just do b squared times b squared. But the tricky part was figuring out what two numbers multiply to 225 and will add to negative 61. But before I dived into that, I wanted to set up my factors because I realized there's only two possibilities, but I still needed to figure out what was the number in front of the b squared terms. Ultimately, I realized that 25 times 9 multiplies to 225. And then I realized that if we multiply 9 times 4, we get 36. And 36 and 25 add up to 61. So I had found the numbers that need to go in front of the b squared term. But I didn't stop there, because I realized that I could factor this even further, since we have two differences of squares. We have 4a squared minus 25b squared. I can write this as 2a minus 5b times 2a plus 5b. Then we have a squared minus 9b squared. I can factor this difference of squares and write it as a minus 3b times a plus 3b. And now we can say that the original trinomial has been fully factored. Of course, I multiplied these brackets out to double check my work, and since I got back the original trinomial, I would say that I did this question correctly and I gave myself a check mark. And then I moved on to question number 2. Here we were told that x is equal to a minus 2 divided by a, and y was equal to a minus 2 divided by 2. And then we were asked to find the value of x times y plus 2 plus x over y plus y over x. And this wasn't that difficult. All I needed to do was replace the x's with a minus 2 divided by a, and replace the y's with a minus 2 divided by 2. So most of the work was just simplifying this equation. And since I knew how to multiply and add fractions, it really wasn't that difficult. The hardest thing is just making sure you don't make a little mistake because there's so many numbers and variables that you're working with. And now what I really liked about this question is that when I simplified it down, I got it all the way down to just a. To me, that's so satisfying. And now you can tell me in the comments if I made any mistakes, but I think I got this question correct, so I gave myself a check mark. Now let's move on to question number 3. Here we were just asked to simplify the expressions. 3a was just a radical expression. It says the square root of 12 plus the square root of 3 minus the square root of 4, all raised to the power of 2. I know that 12 is just 3 times 4, and I know that the square root of 4 is just 2. Then I collected like terms, which got me the expression 3 times the square root of 3 minus 2 raised to the power of 2. I didn't think I could simplify inside the brackets anymore, so I decided to do some multiplication. I multiplied the two terms together, which got me 27 minus 12 times root 3 plus 4. Collecting like terms again, I got 31 minus 12 times root 3. And now maybe I made some little mistakes along the way, but I think that was the answer to the question because I couldn't simplify it any further without a calculator. And so I gave myself a check mark. Now let's look at 3b. This was a pretty complicated looking expression, but don't let that scare you because it really wasn't that complex when you realize that all you need to know is your exponent laws. And so the real challenge was just knowing when to add the exponents, multiply the exponents, or subtract the exponents. However, it is easy to make little mistakes, especially when you don't have a calculator. So I took this question nice and slow and just really worked through each exponent. And again, you can tell me in the comments if I made any little mistakes, but I got my final answer all the way down to just x to the power of 5 over 12. So I felt pretty good about my answer and I gave myself a check mark. Now let's look at question number 4. Now question number 4 asked me to find the square root of this polynomial. And now I've never had a question where I was asked to find the square root of a polynomial. So I'll just be honest with you, I didn't even really know where to start. I just started by taking the square root of the entire polynomial. And then I tried to simplify the inside of that square root. And so I wrote the terms that had the negative exponents as fractions. And then I made sure to multiply the other terms by the correct variable in order to get everything under the same denominator. Now, one thing that made me feel good was that my common denominator was x squared. And I know the square root of x squared is just x. So I was able to simplify it a little bit. And I really didn't know how I could simplify it further because I couldn't factor it as if it was a quadratic, and there wasn't a common factor in all of the different terms. And so I was a little stuck. And honestly, I just moved on to the second part, which asked us to check when the value of x was 10. And so I just plugged x equals 10 into each term. And of course, this took forever because I didn't have a calculator, so I was doing everything with mental math. And ultimately, I got my final answer down to the square root of 48,841 divided by 10. And now, because I didn't have a calculator, I had no idea what the square root of 48,841 was. I did check on my calculator. It's 221. And so that got me a final answer of 22.1. Now, I did not feel confident in this question, and I really want you to let me know in the comments how you would have done this question because it stumped me. And so I did not give myself a check mark on this one. I would say I got this question wrong, which is totally okay. Okay, I couldn't help myself. I was so curious about how I would have found the square root of this polynomial that I decided to ask ChatGPT. And ChatGPT gave me this answer. I was pretty impressed with how in-depth this answer was, but honestly, I'm still a little confused because I've just never been taught this method of finding the square root of a polynomial. What I do understand is why we were looking for a polynomial that would be multiplied by itself to get back the original polynomial, because that's what a square root is. The square root of 4 is 2 because 2 times 2 gets you back to 4. I'm just really surprised that this was for students that would be at a grade 8 level. Makes me think that students in 1934 were pretty smart. So if you have a good understanding of how to find the square root of a polynomial, please let me know in the comments because I'm still curious and I still want to understand this a lot better. Now let's move on to question number 5, which just says solve. So looking at 5a, I assumed we were solving for x. I started with the left-hand side of the equation. Since we had two fractions, I decided to combine them into one by finding a common denominator. Then I expanded out the numerator and the denominator, and that gave me this equation. My next step was to do some cross multiplication, moving that denominator over to the right-hand side of the equation. And that left me with this. I was working with so many variables. Honestly, it's really easy to make little mistakes, so I hope I didn't. But I just took my time, collected my like terms, and started simplifying the equation. And ultimately, I simplified the equation down all the way to where it said 0 is equal to a squared b plus 2abx minus ab squared. And then I realized I had a common factor of ab. So I pulled that out of the equation, leaving me with a plus 2x minus b. And from here, I just isolated for x, leaving me with x is equal to negative a plus b divided by 2. And honestly, I didn't feel that confident with this answer for some reason. So I decided not to give myself a check mark. And you can let me know in the comments if you actually know what the correct answer is or if you think my answer was correct. But regardless, I just starred that question and moved on to 5b. For 5b, we were given two equations. We have x squared plus 5xy plus y squared plus 17 is equal to 0, and we have x plus y is equal to 5. My first thought was I need to use both of these equations, so I decided to use the method of substitution. I rearranged the second equation for y, so we have y is equal to 5 minus x. Then I substituted that value of y into the first equation in order to solve for x. And that left me with this quadratic, negative 3x squared plus 15x minus 42. I realized that each term had a common factor of negative 3, so I pulled that out of the equation, leaving me with x squared minus 5x minus 14. And this was pretty simple because it's just a regular quadratic equation that I could factor by thinking what two numbers multiply to negative 14 and add to negative 5. And now one thing I realized I forgot to do was I didn't go back and solve for y, but that would have been easy. I would have just plugged in the values for x in order to find the two possible solutions for y. I felt pretty good about that question, so I gave myself a check mark and moved on to 5c. Now 5c was this equation. X plus the square root of 2x plus 1 is equal to 7. In order to solve for x, I realized I needed to get rid of that square root. The easiest way to do that is to raise both sides of the equation to the power of 2. That left me with this, which I just needed to simplify. And once I did that, I was left with this quadratic, x squared minus 16x plus 48. And so I had to think what two numbers multiply to 48 and add to negative 16. And this wasn't that difficult. I realized it was negative 12 and negative 4. And so the solutions to this equation would be x is equal to 12 and x is equal to 4. Now here's the thing. I realized that even though I have two possible solutions, x is equal to 12 and x is equal to 4, only one of the solutions is correct. Because when I plug x is equal to 4 into the original equation, everything works out. But when I plug x equals 12 into the original equation, you can see we have an issue. 17 does not equal 7. And now what this told me is that the only solution to this equation is x is equal to 4. And we can use Desmos to visualize this. When the function has a y value of 7, the x value is 4. And that's the only x value that gives a y value of 7. And so that's why x is equal to 4 is the only solution to this equation. And with that, I moved on to question number 6. So looking at question number 6, we have these two linear equations, and we were asked to solve for their point of intersection graphically and then verify that answer by solving algebraically. So let's start by solving graphically. I have drawn my x and y axis, and I need to plot each one of these lines. I can do that by rearranging the equations so they're in the form y is equal to mx plus b. For the first line, we can see that the slope is negative 2 over 3, and the y-intercept is 2. I can plot that on the x and y plane just like this. For the second line, you can see that the slope would be 4 over 3, and the y-intercept would be 8. And I can plot that on the x and y plane just like this. And from this graph, you can see that the lines intersect at the point negative 3, 4. Now let's verify this algebraically. We can find the point of intersection between these lines using the method of substitution or the method of elimination. It seemed a lot easier to do the method of elimination, and from there I could just solve for x, which would be negative 3. Using that value of x, I just plug it back into one of the equations and solve for y, which you can see is 4. And since that matched the point of intersection that I found graphically, I would say that I did this question correctly. Now question number 7 totally stumped me. I've never seen a question like this. We were asked to form an equation where the roots of the equation were the squares of the roots of 2x squared plus 3x minus 7. Now roots are just x-intercepts, so I was like, okay, I'll solve for the x-intercepts for this equation. But it wasn't that simple because I had to use the quadratic formula in order to find the roots. So that left me with these terrible looking fractions that I really didn't know how to work with. They had asked for the squares of the roots, so I raised both roots to the power of 2 and multiplied that out in order to get these values. Once I had the squares of those roots, I was like, okay, I guess I need to make an equation. So I just wrote a factored equation like this. Now I really want to know if you understood how to answer this question because I did not think I did it correctly, so I did not give myself a check mark and I moved on to 7b. Okay, I couldn't help myself again, and I decided to ask ChatGPT how I would answer this question. And oh my goodness, Chat gave me this just ginormous answer using some equation called Vietta's equation, and there's no way that this would be the easiest way to answer this question. And I really don't think that a teacher marking an entrance exam would want to see all of this work. So then I decided to ask our old friend Google. And I found this one solution on this homework help website. And it's a little simpler, but I don't know. I still feel like I would have needed a teacher to show me how to do this, and then I would have been able to answer the question. Let me know in the comments how you would have answered this question, and if you know an easier way to find the squares of the roots of a polynomial. 7b said, using the formula, which I assumed was the quadratic formula, find the roots of this trinomial and then prove that they are real. So we have px squared plus 2 times p minus q times x minus 2q. Now, I know how to use the quadratic formula pretty well, so I just plugged in the values and then simplified as far as I could. The problem was I couldn't really simplify it that far since I was working with variables, not known values. So these were the two roots I got. But now I had to prove that they were real. The roots would be real if we plugged them back into the original equation and the output was 0, because x-intercepts occur when the y value is 0. And so that's what I did. I plugged in one of my roots into the original trinomial equation. And oh my goodness, this was a behemoth of a simplification. There was just so many variables to work with. I got so overwhelmed. But ultimately, I was able to break it all the way down to 0. So I did prove that the first root was real. But I was so exhausted, I didn't even want to check with the second root. Based on the last answers that I was Googling and asking ChatGPT from, I definitely think that I was not prepared to answer this type of question. The students who would have been writing this exam would have learned how to answer these types of questions. It seems like these types of questions are not really part of our curriculum anymore, so I've never been exposed to them. But it's really eye-opening seeing where there's gaps in my knowledge. So for me, this is actually quite exciting, and it opens the door to learn a lot more and really understand these quadratic equations on a deeper level. But anyways, I did not give myself a check mark, and I decided to just move on to question number 8. Now, I really liked question 8 because I really like word problems. So this word problem told us that we have a rectangular garden that is 80 feet long and 22 feet wide. And we want to build a path of uniform width around the garden. All we know is that the area of the path is going to be half of the area of the garden, and we are asked to solve for the width of the path. Since I knew that the area of the path had to be half the area of the garden, the first thing I did was find the area of the garden and then divide it by 2. So the area of the garden was 1,760 feet squared, which meant that the area of the path was going to be 880 feet squared. Now, the next thing I did was I looked at my diagram and I realized that the total width of the garden plus the path would be 22 plus 2x, and the total length would be 80 plus 2x. And I realized then that I could find the total area, which would be 22 plus 2x times 80 plus 2x. I multiplied both brackets out, and it got me this equation. And now this equation represented the total area. The total area is 1,760 feet squared plus 880 feet squared. So I replaced the total area with 2,640. Then, when I simplified the equation, I was left with this quadratic. And since I had a quadratic equation, I thought, okay, I just need to factor this to solve for x. I started by removing the common factor of 4, and then I thought, what two numbers multiply to negative 220 and add up to 51? And I realized that would be negative 4 and 55. And so the solutions for this quadratic would be x is equal to 4 and x is equal to negative 55. Now it doesn't make sense for the width of the path to be negative 55, so I knew the only possible solution would be x is equal to 4. And a 4-foot wide path is pretty typical. So that answer made sense to me, and I gave myself a check mark and moved on to the final question. Question number 9. So question number 9 told us that we have a right-angled triangle, and the perimeter of this right-angled triangle is 5 times the length of the shortest side. And we want to find the ratio of the lengths of the sides that are along the right angle. I started by drawing out a right-angled triangle and labeling the 3 sides A, B, and C, where C is the hypotenuse. I then wrote out an equation for the perimeter, which would just be A plus B plus C. And I replaced the perimeter P with 5A because I designated A as my shortest side, and we were told that the perimeter is 5 times the length of the shortest side. I then just simplified the equation to give me 4A is equal to B plus C. Now I was stumped for a little bit, but then I decided just to play around with another equation that I know I can use for right-angled triangles, and that's Pythagorean's theorem. So we have a squared plus b squared is equal to c squared. And I decided to use my perimeter equation, rearrange for c, and then replace c squared in Pythagorean's theorem with 4a minus b. And when I did that, I was left with this equation, which I needed to simplify. And I simplified it all the way down to 0 is equal to 15a squared minus 8ab. I then rearranged the equation to give me 8ab is equal to 15a. I canceled out the common factor of a, leaving me with 8b is equal to 15a. And from there, I just needed to rearrange the equation to get my a and b variables on the left-hand side and get my coefficients on the right-hand side. And that left me with this ratio of a over b, which was equal to 8 over 15. I felt like that answer made sense, so I gave myself a check mark and I finished the exam. Honestly, this was a lot harder than I expected. If you think about it, this exam was for a student in grade 8 looking to go into high school. I don't know, ask yourself when you were in grade 8. Do you think you would have had all the knowledge you needed in order to answer these questions? I don't know if I would have, because as a 24-year-old university graduate, I still struggled with some of these questions. It goes to show you that the expectations were a lot different back in 1934. Now I decided to give myself a rough estimate of how I had done on this exam. Since there was about 15 questions, and since I had given myself a check mark on 11 of them, I would say that I got about a 73%, which is pretty darn good. I challenge you to try this exam yourself and to give yourself a grade to see how you did. Thanks for listening. I hope you like this type of video because I found it really fun to go back in time and challenge myself like a middle schooler in 1934.